today's class, guys, is going to be all about all about those two things. So first of all, the first concept is composite functions. Okay, composite functions. Now, composite functions, it's really easy. The implications thereof is going to be kind of huge, okay? Because what we are going to do with composite functions is later on, especially when we're working with things like differentiation and integration, you know, composite functions are going to be there. Now, composite functions you've done before. Hashtag just saying you just didn't know that you did it. Okay? When you hear the word composite functions, what does it mean to you? Say to me, what does it mean to you? Come.
I know what a function is, like some of those graphs, but composite.
Okay, so let's quickly talk about the word functions. Okay? I want to replace the word functions, but I'm not going to, okay, because then you guys are not going to have a cooking clue what I'm talking about because you haven't done it in core maths yet. The actual real thing should be composite relations, not composite functions. But let's just stick to composite functions for now. A function is what, in your mind? Tell me.
Functions are, it's one of, it's basically like a thing that helps you determine like how a graph would look on a scale. So,
Okay.
that's like a mathematical. There's like, I think a function is like English, and then there's a function in mathematics, and a function in mathematics.
So what is a function in English?
Something like a process that goes through a function.
They're looking at them and they're all staying quiet. They're all going, what is he talking about? Okay?
A process that happens like in a system.
So why do you think that that's different in maths?
So math isn't the same as English.
But actually that's exactly what a function is. Even in maths. A function is a process that your variable goes through to get to another variable. So we do stuff to the x value, and you do stuff with it, and you end up with some y value. That's exactly what functions are in core maths. Okay, so no, maths and English are not two completely different things. Please don't worry about that. Okay, it's actually the same thought pattern. Okay, when we go and we draw a function, it becomes a what? A graph. Okay, when we draw the y values and we connect them and we make beautiful lines for them, it becomes a graph. Now, I'm saying this very clearly that up to this point, Fenway in the trick, you guys have used the word function very flippantly. Whenever you thought about a process or an x relating to a y, we spoke about a function. In reality, there are functions and non-functions, and you are going to do that in core maths. I'm not going to get involved with that discussion. But if you think about it in very plain language, a function is just a recipe. Okay? If you are cooking food, okay, your x is your ingredients, and your y's are going to be your actual food, the dishes you. If I change the recipe, I'm going to change the outcome. So I'm going to have a domain on the one side, and the beautiful word for this in the maths language is we map it onto. So I'm going to take x values and map it onto a range. So when we talk about functions, yes, same process, something happens. Now what does the word composite mean? Fenway?
You combine them.
Combining them. Okay? So combining functions. Okay, now you guys have been doing this for many years. You just didn't know about it. Okay. So when we talk about composite functions, and composite meaning looking at two different functions, I first want to get something out of the way, because without this you're not going to understand what I'm talking about. Okay? Let's look at that function. Okay, again I use the word function flippantly because I don't really understand about, you guys don't understand about non-functions. So flippantly I look at that function. What does that mean? Fx equal to x squared minus 9. What does it mean? Fenway?
In which way?
What does it mean? What does this represent?
A linear function.
Linear function.
Oh, it's a parabola.
It's a parabola. So what does it mean? It means this is a function that takes the independent variable. Let's talk some physical sciences and some life sciences. An independent variable, an x value. It squares that x value, and from that answer I subtract 9, and so I have an input value, and then that gives me an output. And I'm saying this very clearly. This is all we are doing is studying the output values. Okay? So Fenway was right eventually. This is a parabola because degree of the polynomial is 2. Now, what does f of 3 mean? What does it mean? Not what's the answer, what does it mean? And what does that mean? I'm not asking you what process we follow. I'm asking what does it mean? And what does that mean? I'm trying to guide you. Whenever I put x equal to 3, the answer is going to be the y value when x is 3. F of 3 means the y value of the function when x is equal to 3. So this is a set of coordinates. 3, f of 3. So whenever we talk about f of 3 or g of 3 or h of 3, we're talking about position. Okay? That gives me position. Now, this is crucial you understand this, because by the end of grade 12, you are going to have about core maths 3 different notations. Then you're going to bring in AP maths, and there's another 2 or 3 other notations that you are going to have to be careful of. So position. And what is this Y value? Fenway has got it about 5 minutes ago.
I wasn't looking.
Okay. If I substitute 3 in, yeah? 0. So again, now that is a position on the graph. When x is 0, y is 0. Okay? So position. So quickly just what is f of a? What is f of a? Remember, fx is still x squared minus 9. What do I do with every x? Replace it with? So what is the answer? Okay, let me stick to the green. A squared minus 9. And that's your answer. So as a set of coordinates, a comma a squared minus 9. Okay? Sounds okay. What does that mean? F of x minus 1. Okay? What do I do? Yeah. So in other words, okay? Now let me blow your mind a little bit. This, ladies and gentlemen, you've just done is a composite function. Because what if I tell you g of x is equal to x minus 1? Now what kind of a graph is g of x? Linear. And what am I doing here? F of g of x. Because wherever there's a gx, it means the same as placing x minus 1. So this is x minus 1 squared. Well, let me first write it this way so you guys just get the clear message. Wherever there's an x, I replace it with g of x. So that's what this means. But what does gx represent? X minus 1 squared minus 9. Now my question that I want to ask. Ooh, now we're going deep here. What is the effect that gx has on f of x? Come on, my further studies group. What is the effect that gx has on fx? Fenway.
Shift.
Which direction and how far?
To the right. By
1 unit. So actually, the composite function, the meaning in terms of the effect on fx is actually going to be a shift 1 unit to the right. Okay, that is the effect that it's going to have. So, have you been doing composite functions?
Yes.
We have. We just didn't know about it. Okay? We just didn't know about it. Okay, so I spoke earlier about different notation. So what we are doing is now, Fenway, we are going to introduce our first really new notation. Okay? Our first new notation that I'm going to speak about was, if I've got fx being x squared minus 9, and I've got gx being x minus 1, I don't have to put it in brackets, f of g of x, I can also write like that. F circle g of x. That means exactly the same thing. Okay, that means exactly the same thing.
Is the O like a symbol? Circle like a symbol?
Yeah, it's literally a circle. F circle g of x. And this means replacing every x in fx with g of x. So the answer to this is x minus 1 squared minus 9. So what is g circle f of x? Please tell me what. So if we write it in normal notation, it means g of f of x. So in other words, wherever there's an x in g, I have to replace it with f of x. So what's this going to be? Replace every x with. So in this case, it's going to be x squared minus 9 minus 1. Which I can simplify to x squared minus 10. Okay, this is simple, guys, really. So let's go all inception on this. Calculate f circle f of x, g circle g of x, and then lastly, f circle g circle f. What is f circle f going to be?
So it's brackets x squared minus 9 squared minus 9.
Okay. Okay. So it's literally just substituting f of x into f of x. And g circle g of x.
X minus 1 minus 1.
So x minus 1 minus 1. Okay? So literally going wherever there is an x, substitute g of x. So f circle g. Now, of course, I can make it interesting and go 3. Okay?
So I didn't get the initial one.
So if I look at this, I would go f of g of f of 3. Okay? Do you want me to first do the x1 and then with the 3? Okay, so let me quickly do that. Let me not jump the gun there. Okay. Okay, so let's do the x1. So what I love to do is kind of break it up a little bit for myself. So let's look at g of f of x. So g of f. So substitute f into g. Okay, we did do that already. Okay, but for our uninitiated here, that is going to be x squared minus 9, that is f of x minus 1. So simplifying it a little bit gives me x squared minus 10. With me? So now that, remember, is that part there. So in other words, I'm actually wanting to calculate f of x squared minus 10. So in fx, wherever there's an x, I'm going to put x squared minus 10. So this is going to become x squared minus 10 squared minus 9. And you can go and sub in further, okay? Or simplify out further, not sub in further, but simplify out further, okay? But I mean, it's not the end of the world. But what if I replaced this x with 3, for instance? So in other words, replace the x with 3. Start right in the middle. Go. What is f of 3? F of 3. 3 squared minus 9. So that is 0. Which means this changes into f of g of 0. Now you do g of 0. So g of 0. So 0 minus 1. So this is then f of negative 1. And this is then negative 1 squared minus 9. And this is negative 8. So you literally take this a little bit, by little bit, by little bit. Start from the inside, work out. Now, we're not going to ask, or let me rather not say that. I haven't seen them ask a lot of times this as is, just like this in an exam. But the knowledge of composite functions and decomposing functions from this is in every single exam. So the applications of composite functions are crucial for your exam. So let's quickly do, and we are going to do a lot of these exercises, so I'm not going to spend too much time on it. But what if I bring in last year's work? and I ask you, determine f circle g of x. Determine an expression for that.
So let's see what we want to do.
I do this on purpose because you guys forget something. So, Fenway, you guys forgetting something. If I say f circle g of x, you've got to replace every x with 2x minus 3. So not just x,
Okay.
but also
That takes.
x. Every single x you have to replace with g of x. Okay? So how is it going to look? F of x equal to?
2 minus 3 squared.
If
2x
2x minus 3
greater than 1.
and the second one,
3 to the power 2x minus 3 minus 1.
if
2x minus 3 less than or equal to 1.
so now I just kind of have to go and say, okay, I'm not going to worry too much about the simplification. But this answer, transpose the 3 or add 3 on both sides, divide by 2, x is greater than 2. X is smaller or equal to 2. I have seen him ask this in an exam. Okay, I have seen him ask this in an exam. Very crucial. Okay, where they ask you F and G and then substitute in. But substitute in everywhere. Okay? Everyone alright there? So a silly mistake that you've just got to kind of be aware of, that every single x must be replaced. Okay, so again, I'm not going to spend copious amounts of time on this. Okay, sorry, I made a stupid mistake. That shouldn't be f of x, that should be f of g of x. Okay? An interesting little tidbit, okay, completely useless information that I didn't even know until about 2 years ago, is that in maths, that is actually, ladies and gentlemen, f squared of x. This is g squared of x. Okay? That is the acceptable notation. If you see g squared of x, it means g substituted in g. F squared of x, f circle. Okay. Everyone alright with it?
Basically, that always like that circle like a multiplier. Like so.
No.
But because they're not like
I get what you're saying. That you kind of want to go g times g of x. It makes my heart feel better.
yes.
But no. The circle is just there for saying that I'm substituting something into something else. Okay. And ladies and gents, this is it for composite functions. Okay? Now later on, we are going to spend more time going from our end result to the beginning. You know, giving you a composite function, and you've got to figure out which one was, which is the outside function and what is the inside function. Okay? But we need to first do this before we actually get there. Okay.